Yesterday we have gone through the introduction of inheritance, right?
Yes.
So in this session we will continue further with the topics of inheritance. What is composition? What is aggregation? What is the difference between all these three with examples, right? Okay.
Okay.
What is meant by composition in general? Yesterday we have seen one example, correct? Where we have a person is having a robo object, right?
Yes.
So in that sense, a person is object has a robo object, right? So a person consists of robo inside it. If you see visually, that means it is a relationship we can call it as a composite relation. That means what we can say, I opened the robo example yesterday's. See here, I am declared the object of person here
Yes.
with reference P1. While creating this object, I have passed on the another object to it, right? Robo object R2. Can you see? Can you see screen? Hello.
Yes.
So what does it mean? The person object contains robo object, right?
Yes.
So that type of relationship is called composite relation. Understood?
Okay.
What is the use of this composite relation? I can access the robo object using the P2 object or P1 object. Correct? That's what I have done yesterday, right?
Yes.
I have controlled the robot using the P1 object, right? So
Yes.
using this composition principle, I can access members of another class, right? That is the purpose. If I don't pass on the reference R2 here, I will never be able to access. Some connection should be there. So that relationship
Okay.
is called composition. Okay. Now I will close it now. This file. Now what is inheritance? In inheritance also, I can access the members of another class, right?
Yes.
I was inherited. So the child class can access the members of parent class. Correct? But what is the
Yes.
difference between inheritance and composition?
You are accessing
Both
another object.
in both ways, in both conditions, in both principles, we are able to access the other class members, right?
Yes.
But in case of inheritance, I can extend the functionality, right? I can write my new, I can rewrite the existing code, right, of the parent class if I don't want.
Yes.
Suppose some method 1 is there in parent class. I don't want the implementation what is there in it. I can rewrite that code in child class. So I can extend my functionality in case of inheritance. But in case of composition, I have to simply use that class members. I cannot extend the functionality to this other class which has been used in the composition, right? Understood the difference?
Yes.
That is the only difference between them. So where we have to use the composition, where we have to use the inheritance, we will see now. First of all, I will tell you what is composition here. By creation of object, by creation of an object, can access the one class inside another. We can write like this. Otherwise, okay. What is the advantage of composition or inheritance? Why we do both?
To get the feature of the parent class.
No, in composition we don't call it as a parent. In inheritance only we call parent. We use this composition for code reusability. So without writing, I can access the methods and members of a other class by using the composition.
Okay, reusability.
Code reusability. Suppose I have a car class. What is the first argument? Self, right? In method. Model self dot color. There is one more class, employee. Now we will see how we'll build a composite relation between this car and employee. See, in this example, I have a car class and a employee class. Okay,
Okay.
car has having the, what is the type of methods? These are the instance methods, right? One is
Yeah.
init method and second one is get car info method. Always instant method takes a first parameter as self, right? If it is
Yes.
class method, it will take CLS. Okay. Now the employee class employee has one attribute. What is that attribute? Instance variable.
Can you repeat the question?
No, just a second. Some outside disturbance is there. That's why I closed my door. What I have told you, in that employee car, employee has an attribute car. Correct? Here, this is an instance
Yes.
variable, right? Self.car.
Yes.
What I am by creating this attribute, what I am doing is this car object I will pass on to this employee at the time of creation of employee. Understood? Here see. First I have created a one car object, right?
Yes.
What are the attributes I have passed? Car name, what is the model number, what is the color. So I have created one object. This init method will be automatically run and will be updating these instance variables with the values provided. Right? So
Yes.
I have now C is the car object reference, right? Now I am creating one more object, employee, whose reference is E. And employee is expecting what arguments at the time of creation? Employee name,
Number,
salary, and
salary.
salary or not. Okay. Otherwise, I will remove. That is no use. Okay. So employee name, number, and car. What type of car he is using? So I have passed on this C reference to the employee at the time of creation, right?
Yes.
At the this is similar to previous example, yesterday's example, where a person is having a robo, right? Same thing, robo we have passed on to the person object, right? Same thing here, we are passing the object. So now what is the relation between these two? Is it a inheritance relation or composite relation?
Composite.
Since this employee has this car object, this type of relationship is called composite relation, composition. Can I extend this? Suppose I don't want this car info like this. Can I extend this functionality to here and I will print define car info like that? I cannot extend the functionality, right?
Yes.
If they extend, it will be separate copy, not the original one, right? It is not like a parent or child relationship,
Right.
right? So wherever I don't need to extend the functionality, but I simply want to use that class, I will go for composition. How to apply the composition? By simply passing on the car object, like by simply passing on one class object into another class. So we can create a composite relation between those two classes, right? So here what will happen, we will see. First of all, I have created car object, then employee object. I have passed the car object into employee. Then I called on the employee information method, employee info method. So this is the employee info method. What will happen? What will be the output of first output? What will be?
First employee name Pavan. 101.
What is this?
This will that will call get car info method from car function.
Suppose this is self.car, right?
Yes.
Self means here E, correct?
E.
Dot car, correct? Car means
Yes.
what I am passing?
C.
C, right?
Yes.
What is C? It is a object of car class, correct? So it
Yes.
will call the C dot get car info means it will call the car class get car info, right? This method will be called from inside this employee object, right?
Yes.
This you understood this point?
Yes.
Okay, this we will run. If any mistakes are there, we will see in the code. Save. Arithmetic. Any mistake is there? Invalid syntax.
Here, I think you did not close one parenthesis.
Print. In print.
Yes. Yes.
Okay. Next.
In E equal to M, the colon, sorry, what is that? The double quotes are not closed here in E equal to employee.
Okay, single quote, no? Any other thing here? This is the last line only, right?
Yes.
You see, any mistake is there here?
No.
Employee name, number, and car I got, right? Car details also I got. But why this last step is why you can understand? Employee car equal
Equal to none. Okay.
in
E dot employee info.
from where it is coming, employee car. When I'm running this,
Yeah. This only third print is there. That is giving you. It is calling the function and printing whatever inside get car
should not do
info.
like this, right? It will be calling that one. That's why it is printing first, right?
Yes.
Otherwise, I should do one thing.
You should just call that. Should not print that.
I want to display car in employee car info.
You can print a statement, yeah, above that, and then you can just call that function. Yeah.
Indentation should be perfect.
It should there is one space here.
Okay. There is no need of second parenthesis, right?
Yes.
Okay, now it has come correctly. Okay, employee car name. So what is the purpose of this composition? So we are able to use the another class object and its functionality inside employee class, right? In this
Yes.
car class functionality, we are able to use inside employee. So that type of relationship is called composition. In composition, we will not be able to extend this derived class functionality. We cannot say derived class also. First class functionality inside the second class we will not be able to use. So in that cases only we are using the composition. Otherwise we have to go for inheritance. To understand why it has a relationship, because person has a car, right? We can person is a car, we cannot call like this, correct? Person
Yes.
is a car is not correct, right? Person has a car. So composition is always has a relationship. Okay. So inheritance we can call is a relation. A child is like a parent, right? So is a way by which whatever the variables, methods, constructors available in the parent default are available child class objects. Here also same thing we are defining. Whatever the variables and methods are available in the first class, we are able to reuse. But what is the difference between composition and inheritance?
In inheritance, we can extend, we can change the functionality of the.
The main difference between composition and inheritance extend the existing functionality inside the child class by adding new implementation. So in such cases, we will go for the inheritance concept, where we want to extend the not only use the existing class, but we want to extend the functionality. In such cases, we will go for the inheritance. So here also the advantage is we can use the code reusability. Advantage is code reusability only. How to extend? One second, I will show the syntax. Syntax for this child class. Inside brackets, we will write parent class. Understood? That is the syntax. How we have implemented the composition? By simply passing one class object, right? One class object into another, right? In that way, we have
Yes.
implemented the composition. But what is the way to implement inheritance? Simply, we have to put the parent class name inside the parenthesis while defining the child class. Okay.
Okay.
So now we'll define the parent class first. Class P. Here a equal to 10 is class variable, right? Because it is outside of any method. Inside class, but outside of any method. Self dot b equal to 10. I am declaring and assigning the instance variable b with 10. Okay. I'm defining method 1 here. The first parameter is self anyway. And write like this parent class instance method. Now I'm declaring the class method. Class by using class method decorator. The first variable is CLS, right? Inside class method of parent. It's static method. Static method don't require any self or CLS variable, right? So here I am not passing other variables also. So no need to give any variables inside the parentheses of N3. So this is the inside static method. Static method of parent class. Now I am declaring class of child, which is inherited from P class. Okay, inside parenthesis I have to write, right? Now here I will simply use the pass. I will not write any implementation. Now I will check, because this is a subclass of the parent class. I will check whether I am using the C class object, whether I am able to access the members of P parent class or not. Let us see. Okay, that is a reference variable for C. This is the creation of the C class object, right? C comma A, C comma B. No, any other example? I can call like this, C dot m1 is the instance method. I can call like this, correct? C dot m2 is
Yes.
class method. Even though it is class method, I can call using the reference variable, but this reference will be converted to inside by Python virtual machine as a
M2.
C dot m2 of C. It will be converted like this, okay? So static method anyway, it is not expecting any CLS or self variable, right? Normally, so we
Right.
call directly C dot m3. So we are creating child class object and trying to access the parent class members using this. Okay, see whether we can able to access or not. So, this is inheritance. Both are having 10 now. Okay, we'll change this. See, now we are able to access, right?
Yes.
Access, this is the class variable 10. This is the instance variable 20. B. Now I are able to access the instance method of parent class. This is the class method of parent, static method of parent using the child class.
Child class.
What is the advantage of this inheritance? Suppose if I have not implemented anything, I have simply used the parent class, whatever it is there. If I want to add any functionality, I can add it here, right? By creating some more instance variable or by creating new methods or by overriding the existing method. So I name m1 method, I can override right here and put my method. So while using the C object, first if I am calling C dot m1, it will first check the child class. This is called method resolution, okay? It will first check the child class. Child class have provided any method m1? No, right?
No.
So it will go to immediate parent class for checking Python. The virtual machine then will go to the parent class and checks whether there is an m1 method inside parent class or not. Okay?
Got it.
Then it will execute that m1 method. Suppose it is not able to found the m1 method inside parent class also. Where it will go? It will go to the object class. The object class is the base class for every object inside a Python. Okay, we have discussed in my first class concept. We have discussed every object will be the object of the base class object, right?
Yes.
So it will go and check there. If suppose if it is not found there also, then it will be error, right? At the runtime. That is called runtime error. Okay. So what it will do, it will using the method resolution concept, it will first check the child class for the m1 method, then it will go to the m1 method of parent class it found here. So it will simply execute the code inside it. Okay.
Okay.
This is multi-level or single level or multiple inheritance.
This is single level.
Single level inheritance, right? Okay.
Right.
child class object reference, we can access the methods constructor. In the previous example, we don't have init method also, right, in the child class. So init method also, it will be the same thing. While creation of object, one second, I will open that one. So here C equal to class C object I have created here in this step, correct?
Yes.
But automatically it will call the init method, right? Python. So there is
Yes.
no init method, right? Here, where it will go, it will check whether there is an init method here. Otherwise, it will pass the default init method, whatever written in the object class, right? So in the method resolution order, it will go from child to parent, from parent to parent's original base class, what is it derived from. Okay, so in this case,
Okay.
this init method is initiated first. Okay, because we have already provided init method, the variable b is able to define, we are able to define and assign that variable to 20. So by using the child class object reference, we can access the variables method and constructor of parent class. So in the previous example, I am doing some modifications. See, this is one simple example. Okay, I have taken one parent class. Inside that parent class, class variable is 10, and then I have declared the instance variable b as 20. Now I came to child class. I used p inside the parenthesis to represent as a child class of parent p. Okay, then inside that C class we have variable C equal to 30, correct? And then inside the init method of the child class I have put variable d as 40, which is an instance variable. See, I have created object reference with the C1. This is a child class object creation, right? So will you tell me whether this code will execute or not? What are the codes, what are the print statements will be I will be able to execute here? Can you see and tell me? By inheritance, I can access the members of parent class, right? So whether you see and check whether these members will be executed or not, these print statements.
Okay. Yeah, it will be executed.
C1.a, C1.c, C1.d. Here it will be 10, correct?
30,
Here 30,
40, 20.
here it will be an error.
Okay.
Why it is an error? Can you tell me now at least? What will happen when I create this object C, object C1? It will first call the this init method, right?
Method.
So while calling this init method, it will self.d will be executed, right? So variable instance variable will be assigned with 40. D will be assigned with 40, right? Anyways,
Yes.
this is a class variable. A is class variable. Even before creation of object, it will be available, right? So I can access those items also. But variable D never get accessed because this init
Because the init method will not be executed.
Init method will not be executed because there is only one init method in the child class. If you have created parent class object, by default it would have been executed. But we
Okay.
created only child class object C1 right here. So what will happen? It will first see whether in the method resolution order it will first check whether there is any init method inside. It has found one init method here. So it will simply execute once. That's all. Init method always for one object it will be executed only once. So it will not go beyond the child class. Okay. So this variable will never be assigned by 20. Okay, we'll see now. Save this as inheritance. Sample 2. Initializing the parent class init. See, we have error on print B, right? Print C1.b.
Yes.
So we have to see always that while what members we want and what to be initialized before writing this type of coding. Okay.
Understood.
So what is the remedy for this? So every time
Either we have to create an object.
No. I don't want to create the parent class object, right? Because the concept is I can implement I can access every member of P using C1 reference, right? Child class reference.
So when we are initializing, we have to initializing the child class. We can call that
Correct.
variable.
We have to call this init method manually in the child class, right?
Right.
By using super method. That means it is calling the super class. This super method is an inbuilt method in Python. Like we have print is there, right? We have
Yes.
functions. We have seen right globals, print function, length. So this is also an inbuilt function where it will call the parent class method, whatever we are calling. Okay, so we can just change this like this: super dot
Understood.
init, or we can do like this. We can call any method using class name, right? P dot init. But while calling the instance method using class name, what we have to do as a first argument? Self.
Self.
Because if we are calling using object reference, we don't require self, because itself will be automatically passed. We have discussed, right, number of times. But while
Right.
calling using the class name, here class name is P, we have to pass the self argument. Because this is inside a class, I have used self. If I have to use the same sentence outside the class, means I have to go for object reference. Understood?
Yes.
So either of the two statements I can use here. I'm using super now. Okay, I can use this one also. I will show. Or p dot init. Now there will be no error, right? Will be 20. Save as. See, now I was able to initialize the variable b also, right? So in this way we can use the super method to initialize the parent class variables, right? Otherwise these variables will never get executed, initialized.
Right.
Now we'll see one more example. This is a person class, okay, with the init method. First argument is self name. Self dot name equal to name. Self dot. There is no specification like this. I have to put like this only. We can look. This is local variable, right? We can use any name. Like this also we can use. Okay. But our instance variable name is name and age is, so we can have to put like that only. There is an employee class. So what does it mean? It means extending from person class, right? To initialize superclass variables, I have used in the superclass method inside the employee class init method, right?
Self.
Otherwise I will redo because it is confusing. NA means what? NA. This is local variable. You understood, right? This is the local variable and this is the instance. Superclass, what are the parameters I want to pass? Name and age. So this name and age will be passed on to superclass local variables name and age, and this will be updated like this. I'm creating one employee object right here using small e as a reference. First I have to pass which organ name argument, right? EMP1. His name is EMP1. Okay. Age. Next one employee number, right? Employee number 101. Salary 1 lakh. Okay.
Okay.
So I have passed like this. Now I have to call. I'm calling EMP info inside the employee class. I have to pass any arguments? No, right? Only self is there.
No.
Here, while calling the super method, what are the arguments I have passed? In previous example, I have not passed anything inside, right?
Right.
Because inside we have already self dot b equal to 10. So this 10 already is there inside. So we don't need to pass any value, right, to that instance variable. So we have passed an empty parameter in it in the previous case. Understood?
Yes.
Now, but we have to pass this name and age to initialize this name and age. Understood? How we are passing? We are passing at the time of creation of employee object. So this employee name and 50 age we have to pass through this super method to this person class instance variables, right? How we are able to pass? Why we have used only name comma is here? Why we are not used e number and all? Here e number, e salary. These are not part of the instance variables of person class, right? So
Right.
two variables we are initializing at the time of employee class creation, right? Employee class object.
Yes.
So we need to pass only those variables which are to be initialized by the parent class. So that's why I put name and age only in this. So now we are calling the emp info method using the employee class object, right? See, we got access to the name and age of a parent class using the child class employee, correct? Child class object of employee. Suppose I have removed super here. I can do person dot init method,
Yes.
but what I have to do here? If I do person dot
Self.
self variable, I have to put, right?
Yes.
So let us see. So I can access the init super class init method using the employee, using the employee reference, using the class name, not employee reference, using the class name of parent. See, parent class name is person, right? But now we have to be careful, right? We have by using the self parameter should be the first one we have to pass on, or super method not init of name comma is also we can use. Understood the super method or parent person, correct? How to initialize the parent,
Yes.
right now? So this is also a example for single level inheritance. Aggregation is balanced, right? Aggregation. What is general meaning of aggregation? Aggregation.
Adding together.
Group of things. Group of things brought together, right? We can say like that, right?
Yes.
That are brought together. Composite means Composite means what we call composite object. We can call like this, a group of things that are brought naturally, right, together. We can call like that. Composite element like that will be there, no?
Yes.
Composite substance. That means two elements are brought together naturally and then combined strongly, right? We will not be able to remove these things separate once it is combined, right? Whereas here these things are in aggregate, we have brought those things together. If we want, we can separate them. But in composition, once we brought the things together, it will be one single substance. We will not be able to separate them out. So that is the main difference between the composition and aggregation. In composition, what are the things we have brought together earlier? Per-
Robot and
person and robo, right?
person.
Person and a robo.
Yes.
So robo can exist without person. So there is no use of a robo without a person giving command, right? So we have brought them to,
Right.
and they are just strongly linked. And then robo cannot be survive without a person, right? I will
Yes.
show you one more example. There is an university and a department, right? Suppose there is an university is there, so many departments also will be there inside one university. So if we department can survive without university, so it is under one. No. So if there is no university, there is no department. So that is an example of a composition also, right? Suppose there are some professors are there allotted to each department. Okay, so now here department is a, we can say as a holding thing. Department is a holding thing. Like in case of university is a holding thing. Like department is the holding thing in the second example. So department versus professors. Professors can exist individually without department, right? Some people are general professors will be there, right? They will not be
Right.
there is so there is no compulsory bonding. So we can, if we want, we can bring them together and group them. Okay, if you don't want, we can remove them, but they can exist survive separately also, right? So such type of relation
Yes.
we put them in aggregation. So that is the main difference between the composite and aggregate relationship. Okay, in our example, what is the container object? So department of an university, right? Without the existence of a container object, if there is a chance of existence of contained object. What is contained object? Professor. Existence. We can say that container and contain objects are and such mm, and such a grouping or bonding and such a relationship aggregation, right? So you understood this concept, right? Aggregation, what does it mean?
Yes.
So how to implement the composition? Either by while at the time of creation of the this department object, we will pass on this university object at the time of creation, right? We have seen person
Yes.
and car. Either we can implement using that type composition using the earlier whatever
Okay.
we discussed, or yesterday we discussed inner class, right? Inner classes. So in one class
Yes.
inside another class. So at the time of class creation itself, whether we can define, or if those two are separate classes, if we want to have a composition relation, then we can pass on the container object to the contained object by at the time of creation. That example we have seen today, right? If we want at the time of
Yes.
creation of class to have such type of relation, we will go for the inner class concept. Otherwise we have to go for passing of the one object into another class, another object, as we have seen with the robot and person or person and car examples today. So I will discuss one example, right? Combined example of all these two: inheritance and composition. get car info. What I have to do? I have to car object. What? See here. First, I have taken a car class, right? As we have discussed earlier, right? Okay, with the
Yes.
name, model, and color as the instance variables. I have one more method, instance method, get car info. Here, what I am doing is these are called curly braces are there, no? Inside these curly braces. You understood? These curly braces are called
Yes.
placeholders. So whatever the values dot format we are giving after the values, whatever we are passing on variables, those variables values will be filled inside these curly braces. These are called placeholders. Okay, understood this one? Car name
Yes.
space holders we are giving here. So those empty space holders will be filled up with this name, model, and color. Okay. So we have one more class of name person, and then employee class. Employee class is the child class of a person, right? Inside this employee, we are passing a car object. So what is the relationship between employee and car? The employee has a car, right? So it is a composition,
Yes.
right?
Right.
Whereas person and employee has a parent class child class relationship. That means the employee is a person. Employee type is a person type, right? So employee is a person.
Right.
So it is an inheritance. So all the data from the person class will be inherited to this employee using the inheritance concept. Whereas the card details will be forwarded to the employee using the composition concept, right? So what we have done is here I used super method to initialize the parent class name and age. So parent class name and age is here, right? So we are calling that method at the time of employee object creation, right? So first of all, we have created a car class object, passed on the parameters, then that reference we are passing into the employee class object. Understood, right? This is the example we have seen earlier. This is a combination of inheritance and
Yes.
composition in one example. Now finally
Right.
we are calling the employee info method in the employee class. Let us see. What are the things we are getting over the output? What is the employee name, age, number, what is the salary, and what are the car details? Car details we are getting through composition. Employee name
Right.
and age here are getting through inheritance. Employee number and salary are already in the employee class itself, right? Okay.
Yes.
And composition example. type in end of the iteral. Okay. So we are able to get the employee name and age from the person class. These are inherited parameters, inherited members from parent class of person. So
Right.
car details are we got from the car class object through composition, right? And the employee number and salary we have got from the within the employee class itself. So in this way we can use wherever we want composition, we can use wherever we want inheritance, we can use. So in previous class we have seen only single level inheritance, right?
Yes.
Tomorrow we will see other types. There are 4 more types, I think. Single level is okay. Multi-level and multiple inheritance we have seen. There is a hybrid inheritance also, cyclic inheritance. We'll cover in most probably next 2 classes all these concepts, right?
Okay.
Okay then. Okay, we'll close for today.
Okay. Thank you. Bye.